So we're just going to review anti-differentiation and integration. All right? Let you read the lesson objective. So from here, you know that the gradient function of these four parabolas, they are exactly the same, which is f dash x equals to x. So these are called the family of curves. They all have the same exact gradient function. So we don't know if you're given a gradient function and we integrate the gradient function, we don't know whether it's this one or this one or this one or this one. Alright? So when you actually integrate x or anti-differentiate f dash x, when you come back to the original function, you must remember you got to always add a plus c so that it's a family of curves. That's for all the indefinite integrals. Alright? We'll talk about definite integral a little bit later. Now, the definition. Anti-differentiation is the process of finding the gradient function of some function fx. The anti-differentiation is the process of finding fx with given function. So if dy dx equals f dash x, then y equals fx plus c. C is the constant of anti-differentiation to allow for any arbitrary vertical translation. So the family of curves, it doesn't matter whether it's up and down, you must make sure that you've got a plus c in. Alright, these are, what happened is, once with the arbitrary constant of the anti-differentiation, we have the general solution to the differential equation dy dx equals to f dash x. So that constant of anti-differentiation is linked to the family of curves. We don't know what the constant is unless we've got an initial condition. Alright? So if the value of c is known, this is called a particular solution. Alright, at this stage for today, we're just going to look at the general solution. Always remember plus c. Alright? Now, integration, indefinite integral. Anti-differentiation is synonymous with the term integration. So the notation of indefinite integral is integrating the small fx becomes a large fx, alright? Small fx to large fx plus c. Just make sure that you know there's a family of curves is indefinite integral. We are not looking at definite integral yet, alright? And then, or dx of large fx equals to fx. Here's the notation. Now, we remember the power rule. If d dx ax to the power of n is n ax x to the power of 1, therefore, integrating ax to the power of n dx is ax to the power of n plus 1 divided by n plus 1 plus c. Now, when does the power rule not work? When does this not work? When n is equals to minus 1. When n is equal to minus 1, that doesn't work. Why?
0 on the bottom.
Thank you. 0 on the bottom. So in this case, n, we're using the power rules, n cannot be equals to 1. Alright? N cannot be equals to 1. Right? Just make sure you remember that.
Negative 1.
Negative 1, sorry. Cos 1 it works. Negative 1. My fault. Alright, now, can you try the first one? Determine determine y if dy dx equals to x to the power of 5. 3, there has to be an x at dx at the end. Alright, I've forgotten to type the dx in. So using your power rule, you know that x to the power of 5 is actually from if I differentiate x to the power of 6, if I differentiate x to the power of 6, we've got 6x to the power of 5. Now, there's a missing 6 here. So what do? We can rewrite that. It's actually equals to 1 over 6 times 6 to the power 6x to the power of 5. See? I have changed the appearance of it, but I haven't changed the value. I'm multiplying by 6 over 6, which is 1. So therefore, if I integrate that, I have y equals to x to the power of 6 over 6 plus c. Alright? See, I'm rewriting it that way. So you know that this comes from differentiating x to the power of 6. So therefore, you need to include 1 over 6. Alright? Now the next one. What I would do is, I will actually rewrite it as x to the power of minus 3. It makes life just a little bit more straightforward if you look at it that way. So x to the power of 3 dx, x to the power of minus 2 gives me minus 2 x to the power of minus 3, correct? So I'm missing a minus 2 here. So it has to be minus 1.5 or half times minus 2 x to the power of minus 3. Yeah? If I rewrite it that way, and then I get minus x to the power of minus 2 over 2 plus c. Or rewriting it if you don't want it to be in a negative indices. Alright? So 3, there should be a dx after that. I mistyped that. So I will write this as integrating x to the power of 1/3. Alright? So you've got a power rule, you can use a power rule. Again, rewriting in that form. So I know that is 4 over 3. Yes?
Do you have to put it as a root? Because that's how it...
You can if you want to.
Okay.
But I'm not going to worry about that.
Right.
Yeah, that's fine. That's fine. It doesn't really matter whether it's in radical form or not.
Yeah.
Alright. Alright, do you all agree with me the way I did this tree? Yeah? Very good. So, we're going to go on. Now, the thing is, you've got to know that if there is a coefficient in front of fx dx, you can always take it out. Alright? You can somehow manipulate this, like how I manipulate that. Alright? That's 1 in front of x to the power of 5. So, but I want it to be 6x to the power of 5. So I manipulated that. Alright? As long as k is a real number. Or if I integrate some function fx plus some function gx, I can integrate fx by itself and then integrate gx by itself. Sometimes it makes life a little bit easier if you do it that way. Alright? So think about the multiplication and the addition.
Makes sense.
It's basically the same principle as differentiation. Alright, let's go on. Next example. So, what would I do with number 4? I'm going to rewrite, instead of 6 over x squared, I will rewrite it as 6x to the power of minus 2, so that I have a power function. I use power function. It makes life just that bit easier. I can do that. Alright, so that is actually 4x cubed minus 6x to the power of minus 2. So y will then be x to the power of 4 plus 6x divided by minus 1. So therefore it's minus 1 x to the power of 4 plus c. I must remember my plus c. Always remember your plus c. I know I'm forgetful. Sometimes I do that. Minus 6 over x plus c. Alright?
So,
Yep.
why did you make it a plus?
Let me separate the fraction.
Sorry?
Why isn't it just x to the 4 take 6x to the negative 1 over negative 1?
Because, hang on, have I done it incorrectly? That shouldn't be a plus, that should be a minus. My fault. Minus, so therefore that is a plus. Sorry, it's my fault. Alright, it's my fault. So it's 6x to the power of minus 1 because you're integrating 6x to the power of minus 2. X to the power of minus 2, if you integrate that is x to the power of minus 1 divided by minus 1. Alright? The next one is pretty straightforward. Step by step, do each individual.
This was 6. So it wasn't 13x positive.
Sorry?
Wasn't 13x positive.
Oh yeah, 13x is positive. Yeah.
Alright? These are all just using the power rule. Now, 6, you would have to actually expand it. Expand 6, the example 6, so that you can do the differentiation. Expanding it.
So
Yep.
wait, in 5 for the plus 5, isn't it supposed to be plus 5x?
Yeah, plus 5x, of course.
And that's also 13x.
Plus 5x, of course.
And so in 6, it's positive 13x.
What?
Because it's 15 minus 2.
It's plus, yep, sorry. Alright, it's, hang on, that should be 5x.
What's he done? What's he done, bro?
5.
That which is
Supposed to be
5x,
5x.
that should be
Oh
5.
yeah. And 6 is supposed to be plus 13.
Alright,
2x cubed over 5.
Yep, my fault.
Yes.
So isn't it 2x cubed
That's my fault.
over 3? Yes. Then it'd be 2x cubed over 3. So,
Sorry?
What's this one?
shouldn't the 2x cubed be over 3?
Yeah.
5x cubed.
X.
Yeah, it should be over 3. Yeah.
Over 3.
Yeah, number 5. Question 5.
Question 5, the 2x
Ah, yeah, it is
cubed.
3. Gee, what am I doing? I'm
So a bit tired today?
no. That's alright, I'll sort it out later. Let's try this too, please. Let's try this too, please.
No.
It's easy to make mistake with integration. You're so used to differentiation, it's very easy to make mistake, especially the plus 1 bit
Plus C.
and plus c. Always plus c. Now this one, I will multiply the x to the power of minus half in. Yep. So if I were you, I would just rewrite it, and it should become that. Alright? It's a lot more straightforward if you have the power rule. So 7, it will become integrating 7x to the power of half plus 4x to the power of minus half dx.
You can just split it up
Right.
in a fraction.
Alright? And then you'll get something like this.
Let's go.
So you've got 7x to the power of 3 over 2 divided by 3 over 2 plus 4x to the power of half divided by half plus c. And then rearranging, this is what you get. You don't actually have to put it in radical format in this case. Alright, try number 8 please.
What'd you get from that?
3 on 2.
Number 8 is going to be, it's not going to be that bad because I typed it incorrectly, I'm pretty sure. I'm pretty sure I wanted t cubed rather than
Yeah, I
t
think that's
squared,
right,
but
that's
that's
right.
fine.
No.
Need minus.
No, I did something else.
One of the t should be t cubed rather than t squared.
No.
This makes life a little bit easier for you.
Like this?
Yeah, that's what I got.
Yeah. Easy.
Oh, but I used fucking X instead of T.
So what is
Oh,
How are you
that's the
gonna rearrange
mistake
that?
that always gets me, especially like in calculus.
how are you going to
And
rearrange
you always
that?
use X, and when you copy it off,
Yeah,
and
and you're like,
squared, 2t to the power minus 2.
I've done it so
Or
many times
you
that now I
can
know what it has.
yeah,
I
it was
always
like
know.
I always pick up on it straight.
You can do it this way, or if you like, you can take the half out. That's the same thing as well. It really doesn't matter. Alright? You can take the half out if you like, but you
Just
can
separate
also
the
leave it like this.
Right, like in
So I rewrite this so that I can rewrite everything in the power rule. In the index format.
and you convert to index.
And therefore, I can integrate it.
I missed the plus C again.
You missed plus C.
Bro, leave me alone for
Oh.
That is the bit plus C a lot of people forget. I mean, I made a mistake as well.
I miss it, like, I do half of it with plus C, and then I just miss all one.
Yeah, or
So stupid.
sometimes I'll write everything down instead of plus C, I put down the X.
Oh, okay, that's...
Yeah,
That's a bit
I'll
far.
finish all my integration and I realized that why I didn't put down
Not
plus C, I
that
just put down the X, the X, the X, the X, the X.
Mm.
I would do that because I was just following the, yeah, that happens. Alright, happy with that?
Happy.
That's all pretty much straightforward.
Wait, can you-
So there are some exercises for you to do in
Sadler?
Sadler, yes.
Oh,
And if you like, there's some exercises from Nelson as well. Not
Hopefully the whole chapter.
that difficult. I've done it myself, so I know I could get away with it within about half an hour.
Joke, actually.
So, but some of the questions
I
could
really
be
wanna
a
do
bit
methods.
trickier.
Wait, Abhinav, canteen.
Yeah.
No, KFC? KFC?
Wait, KFC? KFC.